Well, have fun.
Okay, thank you. Hello, everybody. You can hear me? It still sounds like it's not that loud. Okay. Right. I'm going to talk about IPv6 again. Like I've done for about 9 years now, but recently a couple things have happened, and I've learned a couple things as well. For a couple of years by now, I've been trying to tell people that IPv6 is not a technical problem, but a people problem. And a couple of things have happened that sort of show that I was probably right when I said so. A little bit about me. You can read most of that. It doesn't really matter. Basically, I've got a degree in computer science a long time ago in Dortmund, one of the two universities at the time who actually did something with the internet at that time. Other one was Karlsruhe. For some silly reason, I didn't end up in software development, but decided, no, I'd rather do operations in whatever sort of thing. Quite a few years ago, I've been working with an obscure little startup called T-Online at that time. Learned a lot about big systems, about data center operations, that sort of stuff. Did a lot of security things. And when that company got a bit pinkish, I decided it was time to leave. And since about 2003, I've been working mostly on IPv6. A couple other things to make a living, but mostly really IPv6. Written a book on it a couple of years ago. There is a second edition out, but it is not updated. If you get a chance, buy the first edition because it's hardcover instead of paperback. 2 years ago, I wrote a study with Hans-Peter Dittler for the German Federal Office of IT Security, BSI, Bundesamt für Sicherheit und Informationstechnik, on introducing or connecting government agencies to the internet via IPv6. It's still not published because by the time we had it finished, the first people in the BSI realized, ooh, that goes way beyond the network layer. And they're currently rewriting the entire thing together with a parent document that was IPv4 only. Currently, I'm so swamped in work that I'm not working freelance much longer, but I'm actually starting my own company. It's a tax thing in Germany. Okay, you probably know this, right? The TCP/IP stack. We have protocol layers, and all protocol layers only talk to the adjacent protocol layers and all that sort of stuff, which is partly not true and basically useless for our purposes. According to this theoretical construct, IPv6 is a network layer thing. Applications shouldn't actually be involved because they only talk to the transport layer. So basically any application that works with IPv4 should run with IPv6 unchanged, and you shouldn't even see notice a change, which doesn't work like that. We do have a couple things where applications have to reach through the transport layer into the network layer, and we have all sorts of minor little problems that you just have to understand to sort them out. No big deal to do, but a big deal to figure out what actually has to be done. So this picture doesn't really help that much. This is much closer to reality. We have multiple protocol layers. We have the physical layer, link layer stuff, which is actually rather complex. Once we leave traditional Ethernet using some antenna cables and use switch networks, VLANs, port authentication, use all sorts of other things you can do with Ethernet. And once you get into C cables, satellite links, the physical layer, transport layer does get complicated. On top of that, we have the network layer. This is where IPv6 goes, right? Now this isn't to scale. This should be much smaller, but then you wouldn't see anything anymore. This is where IPv6 is, in theory. Problem is, in IT, we have that problem in general, then we pile one thing on top of another. We have the transport layer. TCP is a bit more complicated already. UDP doesn't do very much. And on top of that, we have the application layer. And the application layer is where the vast majority of our code goes. Problem is, when we introduce IPv6, we mess around down here. And in most cases, very little should happen, but because this is so big, there are usually a couple spots where things do go wrong. And you normally don't know in advance where. That's what IPv6, can get rather ugly. Or, no, can get a lot of work, because you have to figure out what's going on inside here. And depending on how your IT was managed or funded, the last about 12 years, basically since year 2000, was the last time management decided, okay, we have to spend some money on IT because otherwise it'll break in a couple of days. We have the same situation right now again. We don't have a fixed date this time, but we do have the same problem. We have to clean up pretty much anything in here. But is that the problem? No, because this picture is also wrong. Or it's missing things. It's only a very little part of the show. This is our TCP IP stack. Layers, no, not really. Cup of sorrow maybe, but we forgot a couple of protocol layers. So what's missing? Well, there's layer 8. People who actually interact with the machines. Users, developers, system network administrators. Yes, they all belong to the same protocol layer, no matter what everybody else says, because they all directly work with machines. They need to learn a lot. Well, not a lot, some. Maybe a lot. You may have to learn a lot if you're the system network administrator trying to keep all those things up and running somebody else 10 years ago built, or 12 years ago, or 13 or 14 or 15, depending when people start to clean up their mess for year 2000. And yes, it also involves users. Even users have to deal with computers every once in a while, and even to them IPv6 might actually make a bit of a difference. Something's wrong with my computer. Well, what's the problem? There's no problem, but there's something wrong. It says some funny things here. There used to be numbers there, now there's letters and colons and numbers in between. And you get these calls in first level support eventually. Better than it. But still, okay, there's something missing. Now this is layer 8, right? What's layer 9? Management. The people who tell other people to do something with the computers. They're the ones in charge of money. Why are they so important? Because these people have to learn and have to realize, okay, we have another year 2000 coming up. We better make sure we have some money at hand so we can get things sorted out. And we better tell our foot folks, take care of it. Now, I've got a rather biased overview of business these days because I've been doing IPv6 training so long. The majority of people I've been dealing with are those where management decided, okay, we might spend a bit of money on this before things get really ugly. The majority of companies apparently don't realize what's going on, at least not in management. So it'll be another, like, no, October 99, whoa, I just seen something my calendar. There's something coming up towards the end of the year. Wow, right? They have to learn about the importance of IPv6 and what it actually means. That it doesn't only mean, yes, there will something happen with our network gear. It may actually wind up all the way to sorting out, we have to spend money on replacing something in here. Just imagine for a moment a small German software company called SAP decides nobody needs this IPv6 stuff and we won't implement it. And you get caught in a situation where you have to replace SAP with something else. That's not something you can do on a weekend shift. That's where a lot of money is involved and where management really has to figure out where to get the budget. To put that, we have politics, layer 10. You probably heard about the privacy concerns, discussions on, yeah, but if everybody has static addresses, they are traceable. So politics get made to do the dirty work for some big ISPs who don't want to give static addresses to their customers and want the politics to take the blame, right? A lot of things are going on there. There's government funding for all sorts of things, blah, 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 blah. So even there we have a number of impacts. Good thing is, at least churches are not yet getting into the game. We'll see what happens when they do. Okay, now is vintage IPv4 a dying business model? Yes. Why? Because new ideas, new business ideas, new features, whatever, fail simply because there are not enough addresses. If I came up with a network Tamagotchi sort of thing that needed an address, and I'd sell it for about €3 per piece, but they needed a globally routed address. That'd be a waste of time and money and effort to build based on IPv4. Simply, it would be obvious we don't have addresses for that. Keeping IPv4 alive gets increasingly more expensive. Why is that? Have you ever tried to set up a VPN through 4 layers of NAT? I had a customer who had to do that. And it's not fun. Their customer paid him a lot of money to get this sorted out somehow. And every time this stuff breaks, which can theoretically happen due to NAT, they lose money as well. So IPv4 is getting more expensive. We will have reduced functionality. Basically means ISPs are currently working on something called carrier-grade NAT. NAT gateways on the provider side, which is extremely painful for them, which is frustrating for you. First of all, reliability of your fancy DSL lines will get even worse than it is today. Second, because you can't do any reverse NAT anymore to run your own services. So we have a number of rather ugly impacts here. What's even worse, and I've heard about that first time about a year ago, and it took me a couple of days to realize how important this is. Things like GeoIP will actually fail. Basically means somebody runs a web server you use, like Google, for example, and they're providing a service for free, right? So who's paying for it? No. The people who place ads on their service. Only if you want to make money through web-based advertisement, you want to know where a certain request is coming from. because it doesn't make much sense. You're in Nuremberg and get an ad for a brand new beer garden in Hamburg. Doesn't make much money. So basically companies who are financed through this sort of localization-based advertisements will have to find other ways to finance their infrastructure and everything. Easiest way to do that is move away from IPv4 and move to IPv6. Sorry. Yes. This means all the assumedly free services on the internet will break down within the next couple of months, which will drive everybody towards moving. Okay, now we have to go for IPv6, otherwise we can't provide this content anymore. Scary, right? We will see a very, very, very quick rush towards IPv6 at some point. Still, IPv4 is a business model. Hey, large scale carrier grade NAT, that's cool. We can make a lot of money out of that. If you're called Cisco or Juniper or whatever. If you can sell this stuff, it's a hell of a lot of money. That hardware isn't cheap, and no, you can't just use a couple Linux boxes for that. Sorry. In the carrier business, we're talking about 100 gigabit Ethernet lines. You can't cope with that using software. Not even on Linux. No, not on Windows either. We have to do that in hardware. Hardware is expensive, and the companies who actually build that stupid hardware make a lot of money. So they're very happy about this. And they even throw in some transition technologies. Not exactly for free, but they do all the standardization work in the IETF, the Internet Engineering Task Force. We will get a lot of these, and a lot of them are meant to make certain people a lot of money, a lot of your money. So this is a great thing currently going on the IETF. All sorts of people coming up with all sorts of funny ideas how to sort of do something for the transition period from IPv4 to IPv6. And most of the things, if you think about it, the only ones who actually get the benefit out of it are those who actually sell that stuff, that stuff to you. And something else that's probably going to happen, some people will make money by providing workarounds about the limitations of CGN. Even without CGN, we already have a lot of people who just pay significant money for a root server in a data center with static addresses because they can't get a static address for home, where they would otherwise run their server on some old machine they put in the basement. That will get worse. So, and then there's something else. Last week there was a RIPE meeting in Ljubljana in Slovenia. The RIPE is one of the 5 regional IP registries throughout the world, covering Europe, Middle East. And that's where a lot of ISP sort of people mostly meet twice a year. And there was one talk by an American lawyer, and she gave a talk on how to transfer IP addresses or relocate IP addresses. Basically, sell and buy IPv4 addresses. IP addresses can't technically be sold or whatever, or bought. But, you know, whenever regulations or whatever say that you can't sell them, you can't sell something openly, you develop a black market. And that's big business right now. And she actually had the guts to go to a RIPE meeting and talk about how to do this sort of business. And not even a certain Randy Bush, I don't know if anybody here knows him. Now he's the sort of guy, he's always good for a rather good remark on anything like that. Even he didn't know what to say about this. Okay, at least the woman, she had guts to go there with this. This is getting a real problem. And it's going to be everybody else paying for this. Why? Because every time we transfer addresses in a rather, we sell what we have way, means these addresses create extra routes in the default free zone. There where the routers don't have a default route. Those are big machines, and we talk about 100 gigabit interfaces, we even talk about terabit interfaces. You have to implement routing tables in hardware, and that's really expensive. In that line of business, even Cisco is cheap stuff. And eventually all of us will pay for this, because through whatever we pay for our internet access winds up going into that. So, what's the business value of IPv6 then? Okay, none. Yeah, IPv6 doesn't have a business case, except for some people doing trainings and okay. But year 2000 didn't have a business model either. We still had to deal with this. And even management still had to deal with this. So if you try to tell your management that they should be aware of IPv6 and they should actually take it into consideration when it's come to budget and task prioritization, be careful when you tell them. They might get a bit upset, but it's still the point. Try to be diplomatic for a change. Thing is, that entire internet thing, you know, like 20 years ago, it didn't have a business case. About 20 years ago, I was told, no, this internet, nobody needs that. We've got telephones, we've got fax machines, and we send a printed catalog to our customers, what, every 3 months or so. Internet, at that time, was not something that had a business case. The business case in that time was to get rid of fax machines, the printed catalogs, and whatever. So the business case for IPv6 is not IPv6, but getting rid of IPv4. Once you get rid of the limitations of IPv4, then we actually profit from v6, and only then. If you try to tell management, the key vocabulary is opportunity cost. Opportunity cost is basically the money you could have made if you could have made use of a certain opportunity, right? If you only could have delivered like 3 days earlier, you would have made some money. There's no cost involved, but still you lose money because you couldn't deliver. That's what opportunity cost means. So not being able to deal with IPv6 means you lose money because you can't make money you could have otherwise made. Something, you talk to those management people, talk about opportunity cost, they probably think, what's this guy doing? He's supposed to be a geek. But sometimes it helps to think like one of them, sometimes. So, what will happen now? IPv4 addresses should run out sometime around August, according to the latest extrapolations. Unfortunately, extrapolations have shown to be way off about a year ago. In February last year, IANA, the Internet Assigned Numbers Authority, announced that they had given all the last remaining free IPv4 address ranges they had to the regional IP registries, like RIPE in our case. And hang on. 2 months later, there was a RIPE meeting in Amsterdam, and at that point people thought, okay, addresses will probably last until about end of the year, end of last year, and then we'll likely have problems. And in early May APNIC, the Asian Pacific Network Information Center, announced, okay, that's it. We're out of addresses. Basically what happened, when IANA announced, okay, we've given out the last address, everybody, okay, we have to get hold of some addresses before we eventually run out. And they were just gone within 2 or 3 months. That'll happen to RIPE and to us next. We're the next regional IP registry running into that problem. When that happens, IPv4 will get sort of comatose. Basically, it's just lying there, it doesn't move, it doesn't do anything, there's nothing you can do about it. And what we will do is some sort of intensive care work. We will have to keep IPv4 sort of alive the best we can until we're through with deploying IPv6. Once we reach that point and people will realize we have a problem, we will get an exponential development. Exponential development means for a long time you don't see anything at all going on really, and then everything happens very, very fast. Right? I suppose I shouldn't bring any analogies to nuclear meltdowns or anything at this point of time, but mathematically it's pretty much the same. When that happens, anybody who isn't up to it will lose money. You will lose customers, you will lose market share, whatever. You will have to pay significant extra money for second-rate workarounds to keep IPv4 sort of alive while the people already use IPv6. Right? We have a couple problems in certain areas. The ISPs are in a very, very, very ugly situation. First of all, everyone waits for them to deliver IPv6. I can't use IPv6 because my ISP doesn't deliver. Right? ISPs are in an ugly situation. They're the first ones to deal with this at a large scale. That's bad enough already. What's even worse, everybody else pretty much can say, okay, if it doesn't work, we switch back to IPv4 for some time and try to sort things out. When you're an ISP, once you say, okay, we sell IPv6, you have to sell IPv6. No way back. Scary. It is scary. For people working in the ISP business, it is really ugly. ISPs are in that ugly situation. They have to decide on access technologies. And with Cisco and others, trying to come up with, well, what's next week? What's this week's current transition technology? It's probably going to be something way different than they're going to try to sell us next week. ISPs have to decide how do we connect our customers with IPv6. And there's so many different options available. It's almost impossible to keep track of all of them, let alone implement them. Let alone implement them in an embedded device, like those Fritzbox or maybe WRT routers. You simply don't have all the space and the resources necessary for that. ISPs generally need quite a lot of networking skills. You want to find people who really know about TCP/IP networks. The easiest way to find them is go to a reasonable ISP, because they need these people. They have lots of people to get up to speed with IPv6. You can't do that in a 1-hour talk or in a 1-week training, at least not in all cases. And ISPs have yet another problem. They take a very, very serious impact on their first level support. Well, my internet is broken. Yes, sir. What did you? I didn't do nothing. No? You know all these games. Take that. Now, there are some large-scale ISPs with tens of millions of customers. These things do get really, really, really serious. Already talked about the Fritzbox and whatever, access routers, not access routers, sorry, customer premises equipment. implementing all and every variety of transition technology is prohibitively expensive. If you do so, you'll be at least 30 or 50 cents more expensive than your competitor, and that means you lose the business. And what's even worse, if you implement everything, the web configuration interface will have lots of fancy buttons. People are, oh, what's this? Ah, my internet is broken again. It's not a big problem for the big ISPs in this case, like Deutsche Telekom. Because what they do is they have their own specific machines and they kick out everything they don't want. Less features built in, less things to break. If you're a smaller ISP and you buy those standard Fritz boxes or whatever, you do have a problem in support. And if you do a change from or if you deploy IPv6 in a very short time frame, you get a hell of a lot of work to be done in first level support in a very short time window. It's going to be painful. When it comes to the big network gear, we have problems. Once you implement things in hardware, you have a significant amount of money that goes into building every single machine. It's not, well, if you do things in software, you have to develop the software, which is expensive, but then you can deploy it to as many machines as you want. Unless you buy the software externally and pay royalties. If you do things in hardware, you hit the market too early, you're more expensive than your competitors who don't do IPv6. They produce cheaper and people will buy their stuff. And unless you have money enough to survive until IPv6 kicks off and you can say, okay, now you buy our stuff, you have a problem. If you're too late, customers will buy V6 capable equipment that you don't have and they go to your competitors again. Another problem is once you build something like that and you ship something with basic IPv6 functionality, and I mean basic. If something is missing and it's implemented in hardware, you can throw away the hardware. It's not like you send out a software update or firmware update or whatever and things get sorted out. So they are in quite a bit of a problem. If you buy network equipment, keep that in mind. Usually network gear is not kicked out every 2 years, like notebooks, at least in some places. You buy network equipment for a time frame of 5 to 10 years. You buy something at the wrong time, it doesn't do IPv6 properly yet, or doesn't do it at all, but you have still a couple months, years, whatever, to wait until you can buy something new, because it's not yet completely appreciated, tax deducted, von der Steuer abgeschrieben. So you're stuck with some hardware you can't really use any longer, and this management expects you, well, do something about it. You're the technical guy. Yeah, but we need money. Money is your job. Yeah, but this is a technical problem. You take care of it. No easy solution. Basically means latest moment features, things that are currently being standardized will prove troublesome. You can get IPv6 up and running with hardware available today, but there is a good chance some people will come up with some funny ideas and they won't work for quite some time. So this is something for you to keep in mind. When it comes to software, okay, operating systems are pretty much okay. Anybody still running DOS? Okay. Standard software is largely okay. There are a couple things that are troublesome, but not too many. What's really painful is specialized software. Software meant for certain businesses. The more obscure, the more troublesome. It's specialized software for lawyers specializing in border traffic from Germany to Luxembourg. They probably have 5 customers throughout the world, and they decide, nope, we're not going to touch that software, it's not worth the effort. And our customers don't have any choice anyway, because we're the only ones with this. That's where things are getting really, really ugly. Open source is generally better off than commercial software for a number of reasons. First of all, about more than 10 years ago, I guess, there was project in Japan called Kame, and they implemented IPv6 for the BSDs largely. A lot of things have been ported to Linux in the Usagi project, so there was public funding there. And that went to the open source world, not to the big companies. Other thing is, in open source, the good news about open source is you don't have to explain your manager, I want to do this. And what's the business case? There is no business case. Then you do something else. That's what happens in commercial software development, but not so much, or at least not so much in open source development. So we have a significant advantage there. Can be a helpful argument to tell management, okay, we now have to use open source despite whatever you always say about it, and not getting support, blah, 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 and you know this. Right? What will happen with software is that comatose software that nobody takes care of any longer, will die. And that doesn't matter if it's open source or closed source. You have software where nobody understands what it is doing. And you have to make it fit for IPv6. You probably won't do it. You're dealing with some software that you already know, and getting IPv6 in there is fairly straightforward in most cases. But you take, maybe 1 million lines of code, and you don't really know what it's doing, and you don't find anybody you could ask about it. It's just not worth it. So, what that means, we'll get rid of some of those dead pieces of what used to be code, which can be quite a good thing. We get a chance and a reason to move away from this sort of software, even if we have been using it for 10 years or 20 years or 30 years or 40 years. Like all this COBOL stuff we had in the banks in the late 90s. Some still survived. There was very good code apparently, but a lot of crappy COBOL stuff nobody understood any longer was just kicked out. We'll see pretty much the same again, but it means we will have to switch products in a number of areas. So, you're still using what? MMDF? Anybody remembers that? Predecessor to SendMail. And I've seen it in some contexts not too long ago. You will kick that out. You do get a chance to get rid of these things. Consider it a chance. No, and I wouldn't personally want to use SendMail either. I know there are some reasons why you want to use SendMail in very, very specific contexts, but normally I've been managing to stay away from it for 15 years, and I would have now a chance to get rid of it. The remaining places where I might still have to use it. And then there's a problem about support. You see, this is a lot of things you can tell your managers. Where do problems get solved in IT? Well, where do they occur? With our end users, customers, whatever. Problem there, they try to fix it. Which can be a problem in itself, but that's how it works. So, they try to deal with things. Get along with them, arrange with them. You come to work like everybody else, 9 o'clock train in the morning, and you go to your computer, log in, username, password, go for a coffee, have a chat with your colleagues. When you come back and the login scripts still haven't finished, you call support, but not before. That's the sort of thing end users deal with and how they solve their problems, the ones they can deal with. What do? When they run into a problem they can't handle themselves? They call zero-level support, power users. Right? That funny this funny guy, 2 offices down the corridor, who's even working with computers in his spare time. Yeah? Or when we talk about home users, hey, you want to come over for a pizza? Okay. Does it actually boot, or should we reinstall from scratch? Right? You know, these people are really important. These are really important. They understand the language of their end users. They are on the spot. Doing support on the phone is painful. Sitting beside the user is much easier. And, well, they're for free. Not really, but they're around. And there's a big problem with them. You normally don't know them. But basically what you want to do is you want to tell them, okay, we're doing something. When you deploy IPv6, make sure they understand, make sure they know. When they don't know what to do, okay, this time it's not like, you know, open up the mouse and get all the dirt out so it'll work again. Or and take the keyboard and lots of cookies lately. It should work again. Once they don't know what to do, they call first level support. First level support are also quite special. They pretty much always work with some sort of script. Maybe written down, maybe just inside their head. Please reboot your computer. So I, on the phone, know where you are, what you're doing. Then do blah, blah, blah. What we consider extremely painful when we're on the wrong side of the phone. That's the only way for them to deal with the situation in a systematic way. They have to learn new scripts. Takes some time. When they don't know what to do, it goes up to system administration, network administration. Right? And there we fix the real problems. Unless something is seriously broken, then we pass it on to development. Right? Okay, numbers. Have rough numbers of a large ISP, 12 million, depending on the definition, about 1 in 100, 1 in 200, so say 100,000, about 2,000, 2,500, 200, and about 30. Right? If you can solve problems here, it's getting very, very bad the further up they go. So what you want to do when you deal with IPv6 is try to make sure that most problems get solved as far down as possible. Otherwise you don't have a chance. No chance in the world. Only getting all the information necessary down, the experience you need, getting down takes time. And that's what we don't have anymore. We are running out of time. August, right? That's something you want to do. We are way beyond layer 7 here. But that's where the problems are. And then there are even worse problems with the people themselves. I found it hard to believe until I really ran into these problems the hard way. You have long-term system, network, whatever administrator, his late 40s, early 50s. He has, 30 years of experience with running computer networks. And yes, he started with ISDN and UUCP and whatever. And he has to learn a number of new things on IPv6. Yeah. Teaching old dogs new tricks, right? Bad enough. Gets even worse. They have to learn from the young dogs. The ones coming straight from whatever. University, or who have learned about IPv6 already. So I've got 30 years of experience with this, and I have this youngster tell me how to do my job? No way. I've seen that happen a couple of times in trainings. And I really don't want to know what's going on there since I left. I go there for training and you see the problems already, and you just don't want to know what's going to happen next week. We have lots of problems there. We have a huge problem with so-called technical management, or ex-technical management. People who have been doing technical work, who have been system administrators, network administrators, who know about the technical stuff, but did a management career sort of thing. The people who believe that they understand technology, only they understand yesterday's technologies, not today's technology. These are a huge problem. Worst one I've heard of, which is so ridiculous and so obvious that it almost looks funny in hindsight, was there was at a bank in Frankfurt where I live. A couple of years ago, the banks had to introduce some extra monitoring features for money laundering things, whatever. And one bank didn't manage to do that in time. Why? Their CTO knew about programming and programming languages. And he knew what programming language was good. Started with B. No, not BASIC. Not BOBOL. No. BS2000 assembler. Till about 2005, 2006, sometime around that, all internally developed software was written in BS2000 assembler. Because for 40 years, he didn't realize that his knowledge was slightly out of date. Sounds funny, right? It's not in a number of other situations. And this does happen fairly quickly. You do management for 2 years for a suitably large group, and you lose contact with technology. And with IPv6, it doesn't take 2 years anymore. And that's where people get very, very irrational. What do you mean? I don't know my job, the thing I've learned, the sort of job I love, really. Most technical managers much rather do technical stuff than management, right? And you tell them, you're out. Not good. Very, very difficult. And this is a management problem. Management should really take care of this. But you have to deal with the problems. And management themselves have a problem. They have to deal with, okay, they don't understand the internet, but they realize we need it. And yes, email is nice, and going to those late night websites, also nice, maybe. But they have to learn things are different. Now, they don't understand what we do today, but they have absolutely no idea what we have to do tomorrow. It's painful. It's really painful for them to realize we have to put some money in there, and we have to defer a couple other important things because IPv6 is even more important. Difficult. So, what will happen once we start to deploy IPv6? All the problems we've hidden away somewhere will come up. It will get ugly. Anything you sort of, well, I sorted it out sometime later and forgot about that 8 years ago, will show up again, give you a problem. Everybody will be affected to some degree. Yeah. The ones who have very, very limited budget for the last couple of years are in real trouble because they have lots of these old problems, because nobody had time to do their job properly. The sooner you start with cleaning up your act, the easier it is. But I've seen so many IT environments that have been so starved of capacity, of skills and whatever, that they're barely capable of keeping their existing stuff running as is. They will have a real problem. If you have kept things reasonably clean, it's fine. If you still have the flexibility, that means the slack extra manpower that Chris spoke about yesterday in his keynote, then you can get things done quickly and you can beat your competition. That's what you have to tell management again. Hey, if we have the manpower and the skills to get things done quickly, we will increase our market share. Ooh, another one of those words. Because our competitors can do it. Otherwise, if we can't do that, we will lose customers, business, whatever, right? So that's what you tell management. What you don't tell management, or don't necessarily tell management, IPv6 is a great chance for all of us to straighten all those old problems out. I don't know how many of you have been around when this year 2000 thing went up. Yeah, a couple of us are. Glad I'm not the only one. Yeah, basically what happened there, we got a chance to get rid of all sorts of crap. And that's the good thing about IPv6, because after 12 years of waiting, we get another such chance. And that's a good thing, right? We will have a couple problems coming up. Security. IPv6 has huge advantages when it comes to security, if you do it right. And if the implementers do it right. Chances, we will make mistakes. I've made mine already, quite a few of them. Try to learn a bit that way. Implementers make mistakes. But eventually, security will improve with IPv6. I've already sort of mentioned the privacy discussion. Giving people static addresses. Whoa, that's not a good move. I want to be anonymous. Well, then use Tor. Yeah, but you can't do that. It's so slow. Yeah, but you want to be anonymous, right? What's going on there is scary. Politics are involved. Basically means it gets completely random. We'll see what happens there. Quite a few ISPs believe in giving people dynamic addresses, or consumers dynamic addresses, so they can charge extra for static addresses and expect you to be a business customer. We'll see what will happen there. I believe we have a significant chance that some small rogue ISPs will decide we'll give everybody static addresses and get a lot of customers that way. And the important customers, those who understand the difference between a static and a dynamic address, because they're, power users. Where do you get what ISP are you with? So-and-so. Are they okay? Yes. Okay, I'll go there as well. You take one of those power users to switch ISPs, and he'll bring 20 or 50 others. So we'll see what's going to happen there. And then there's another problem with ISPs. ISPs have a huge problem, or two huge problems in combination. First of all, their business margin is very, very small. They make, 3–5% of their money actually stays with them. And they do flat rates to the customers. But they pay by data volume to the upstream transit providers. People start to do funny new things with their 50 megabit VDSL line. The flat rates can be rather painful for them. We'll see what happens there. The good news is, I suppose, the majority of you are on the flat rate end of the line, right? So, that's okay. That's what I wanted to tell you about what's coming up, so you be aware what will happen. I hope I've given you a couple ideas on how to tell your management, give you a couple of ideas of what's going on right now. And, well, questions? No questions. Everybody's completely frustrated. Oh, we have to do IPv6. Shit. I thought that wouldn't happen until I retire, right? Okay.
Well, what I'd like to add is I started 3 years ago to prepare a small ISP in South Tyrol to prepare all departments from service desks, sysadmins, developers to make them aware of the problem, do internet trainings and so on. And what I'd like to add is that we don't only have to get prepared for the switch, but we will have a very long time to run IPv4 and IPv6 together. And that's a lot of work.
Yeah, it's true. That's true. We will need to provide IPv4 for quite some time. Things will probably go faster than we think, but we will have a time frame where we have to do both. The important thing right now is to get IPv6 up and running. Then getting rid of IPv4, well, there's the business thing about it, and make money by not doing IPv4 any longer, but it's not as pressing as doing IPv6, that's right. Okay, good. Coffee break, right? Okay.